Hello, hello. How you guys are doing today so far at PyCon Colombia? Good? Okay, I'm going to try to do not get you bored in this talk. Let's see how it goes. So, I'm Jorge. I work at Huge, and in today's talk, I kind of want you to give an overview about what serverless is, and to discuss some experiences I got working with this. Before, I want to say that I'm super happy having here friends from Huge, friends from other meetups. Thank you so much for supporting me, and let's just get started. So, first thing, I made a huge mistake in the title of my talk. Because when I was thinking in serverless, I thought that serverless covers only function as a service. And I couldn't be more wrong. So let me just fix that. So welcome to Function as a Service with Python, which is the core of the topic today. We're going to talk about some concepts behind serverless, and if I have an application, should I go with serverless? Shouldn't I? If I am a Python developer or a Python fan, how can I do that? And finally, some conclusions, plus a small demo. Let's hope. I'm hoping that it's going to work. So, have you heard about serverless? Yeah, nice word nowadays, right? The way I see this, I might be wrong, is that there are two kind of main areas for understanding this. One is serverless is all this movement that is pointing to managed services. Like the less you spend time provisioning on servers, the closer you are to the serverless concept. And the second concept is function as a service. That is the one we are going to talk about today, right? So I like this definition from full stack Python, and it says that serverless is a deployment architecture where servers are not explicitly provisioned by the developer. This means that basically you can deploy a pieces of software without taking care about provisioning. Right? Notice that it never says that there are not servers. There are servers. It's just like you are not responsible for them. The provider is. And once we get the code deployed, we need a mechanism for activating this code, for calling this code. And those are usually events. So what the developer needs to take care about is how are you going to trigger your function? Which event is going to wake up your function? So that's it. So I like this kind of graph because it represents more or less the timelines we have been seeing from the cloud world. Like some years ago, for instance, I got the opportunity to install a real server in the sense of I got the machine in front of me. And I needed to install the operating system, putting this server behind a rack or a firewall, and it was a nightmare because I was a developer, not the guy who is responsible for the infrastructure. But thanks to the universe, things are getting easier nowadays. Like, after that, we got virtual machines, so services like DigitalOcean offers kind of this nice experience, like I want this machine with this operating system, and you just were doing some clicks, right? Then we move, and we were also able to configure load balancers, networking between these virtual machines. Then we moved, and things like Heroku made me that by that time so happy because I just configured a file, or just put the configuration in a file, and I got the service deployed without touching any server. And then the last shift was functions as a service. Like you're not gonna deploy the whole application, but just units or your application. And I'm going to show you an example later on. How it works? In a simplified version is you write a function, you deploy it, you attach it to an event. That's it. And depends on where are you going to deploy this function, you have some integrations with another APIs. For instance, if you use Google or GCP, you can connect with data stores and other services. And whichever the provider you select is going to work more or less the same. You need a trigger in order to wake up your function, right? So the thing is, you deploy this function, and it's going to be sleeping until something happens and make this function work, or something called the function. So you need to really consider that the function is not going to be being executed all the time. It's going to be sleeping until something happens. Right? Cool. What are the pros? The good things in here is that as we are developers, no need to take care about servers. And really, it's just like that. If you use any provider, probably there are some command lines tools for deploying the function, but you don't need to think about capacity, provisioning. No, just kind of more or less how much data my function will consume or use, in which combination of CPU plus RAM I need to run my function, and no more than that. It scales out of the box, because the provider will do the scaling stuff for you. So if your function is able to attend 1 request, it should be also able to attend 1 million requests with the same code, with the same provisioning that you will do, which is nothing, because you are not going to provision the server, right? Now, your function will scale as much as the code inside the function scales. If you put something in your function, like a connection to the SQL database, then don't expect that much escalation. It will scale as much as your database will scale. So keep that in mind. And something really, really nice. In opposite as with virtual machines, you are getting charged because the virtual machine is always running, even if you don't have traffic. In here, you are going to be charged only for the time that the function will take, right? Only for the time it's going to take to be executed. That's it. So this is really nice, because bills will decrease. But if we want to move to this approach, we might need to change our mindset when it comes to the implementation of our application. First thing, functions. Everything will be a function. It doesn't mean that only one function can be deployed. You might deploy as many functions as your provider will allow, but when you write a function, we need to take care about how fast it would be, need to take care about or make sure that the function will do only one thing, just like the units philosophy, right? Why? The more time your function takes, the more you're going to pay. So keep that in mind. I see the cycle or life cycle of a function like a request. Your function is sleeping, it gets some calls, it wakes up, attends the request, and it will die. So there is no chance of having or sharing data between calls. So functions should be stateless, or the implementation of those, right? And since you don't really know where this is going to be executed, you are kind of not allowed to think in an operating system while you are defining the function. Because in the first call, might be executing on a Windows machine, and in the second one, on a Linux machine, so no hardware affinity. And as we do with regular applications, calling a function might fail. So keep in mind that we need also to implement some backup mechanisms or retries. Then, should I go or shouldn't? Shouldn't. OK. In my experience, there are kind of 2 to 3 indicators that you might stay with a regular approach. If you are using WebSockets, functions is not for you. Why? Remember that the function, after it gets executed, will die. And WebSockets is all about to have a communication or keep a communication with the client, right? So no sockets. If you are serving static content, CDNs are for that, not functions. And also, if you are using relational databases, it's my opinion that maybe not the best thing to do. Not because it's not allowed, but because it won't scale as you might expect. When it's good, or when you should consider to move to serverless, or to fast. If your app or part of your app gets low traffic and at some moment or some period of time gets on spikes and then will decrease again, this is for you. Why? Because while you don't have traffic, you're not going to get charged. And when you get the spikes, you will only pay for that. In a virtual machine on another services, it will be running always, even though you don't have traffic. So, next. Every kind of stateless approach you are using or application that doesn't need to have share information between requests, like a REST API, might fit into the serverless approach. And actually, I'm going to show an example using this. And I have seen that in some projects, they are replacing the cron jobs with functions, because the provider usually offers a kind of a scheduling interface, and then it's going to be just easier to have the scheduling in there and not in our end. So, let me show you kind of some scenarios that I had seen with cloud functions. First one is, I strongly believe that if you are developing a mobile application, if your backend is small enough, you might write your backend entirely using cloud functions. Let's say a few endpoints, one for authentication. You might connect to another services for this. I don't know, kind of crude operations. It might fit. In this case, for instance, let's say that a new user arrives to the database, and I need to notify to somebody else that the user gets in there. So I can connect the event of insertion to a cloud function that will communicate with Firebase, in this case, GCP or Google services, and then Firebase will take care about the notification to the mobile. I don't really need an application for that. I just need a function, right? Next. Cool. I like this one the most because it's the one in which I have been working on, and it's that if you need to receive data from a device, and this device offers the chance of connecting or hitting an endpoint, you might just use a function for receiving the payload from the device. Really. And of course, set the authentication that is required in there. And in this case, there was a router that was able to send data about localization devices. And then I was asked to create an application for receiving this payload. And what I had done is I just wrote a function that received this and the function sends this to data store. That's it. And it scales super cool because, when people got into that place, the router was increasing the traffic and the function just behaved okay. In this case, it's a bit more elaborated. The sensor is connected to a service which is called Cloud IoT Core. This is a Google service for managing your devices. And then on every event in here, we connect to a mechanism that is a publisher subscriber. And then the function is in the middle. Listen for this. Then it was communicating with another service. It's like sending an answer like, hey, turn on this, turn off that. And working in this approach right now, my current project is an editorial website, and we want to move all the content to BigQuery for data analysis. And what we have been doing till now is moving the content manually, like a query in the database, and then all this is done by a script. But I'm working in this approach like when something gets to the database, then I can connect to a publisher subscriber mechanism, which is called PubShot. And then with this, I can take the content and move it to the database, to the BigQuery, or also I can make some calls to another machine learning APIs, which is cool because my application, the core application, is not taking care about anything regarding the data analysis. It's just a function, the one which is taken care of. Or you can also do some nice stuff, like when a commit arrives to your GitHub account, then you can connect through a hook to a cloud functions, and then you can inform to some users on Slack that something has happened in your repo. Fantastic. So everything till now sounds kind of good. Now let's talk about the cons. Selecting a vendor is like getting married. It's really hard to come back. So select your provider wisely. Because once you deploy your functions in one provider, it might be difficult to move to another one. Because one offers some integrations, some quotas, and it might differ from another, right? Next, something called call stars. Remember I told you that while your function is not receiving traffic, basically it's sleeping? Well, when traffic arrives, at least some first calls might suffer something called call stars. And call stars is the time that the function takes to wake up and attend your request. And this means some seconds that your users might suffer in terms of latency. So, vendor restrictions. Google offers some quotas, like this is the size of the data that are allowed to get into your function, or the RAM that are allowed to use. This changes from provider to provider. So make an analysis of provider before you go with one of them. Nice. Let's see how can we implement small function using Python. As I said, there are other providers, but the ones I have worked with is AWS with Lambda, Azure with functions, and Google Cloud with cloud functions. But if you hate providers, then yes, I know you are Polish, of course. It's just a joke, yeah. There are also some options for deploying this platform on-premise, like offering to your developers the chance of deploying functions on your own hardware. So you can use OpenFast, OpenWhisk, and Fusion.io. Now, you might go, in order to create a function, you might go to the provider website and create it from there, or use a framework called Serverless, which is a Node.js package that offers the chance of implementing the functions in different languages, but also connect to different providers. And if you are a Django developer, you might use Zappa or Chalice that are specific to this ecosystem. Now, I'm going to show you how to create a small function using the provider's web interface and also the command line. So let's see. Cool. So once you create a project and an account, you probably will see something like this dashboard. I'm talking about GCP. This example is on GCP. And then in order to go to the function area, we might do some click on functions. And creating a function really from this interface is super, super easy. So we need a name. Let's say just hello. I'm pretty sure that this function is not going to take such amount of run. So I'm going to select these options, because remember, the most resources I use, the more I will have to pay. And I'm going to connect this function with an HTTP endpoint. So I said, you see that different providers will offer different options in here. HTTP is just cool for me. I'm going to use the online editor. I'm not going to upload any code, even though it's possible. And select Python. And if you see, have you ever used Flask? Yeah. GCP kind of uses Flask behind the scenes for connecting these to endpoints. So if you see this function, it might look like Flask or Web App 2. Nice. Let's just go with this example. It's going to print hello world. And something important is that we can define more functions in here. Let's say I have the main function, and I have 2 to 3 auxiliary functions that make the hard work, right? In here, we need to specify which one is going to be the main one. So since I only have one function, that one would be the main one. Let's just create it. Couldn't create, of course, my internet connection. 1 second. Don't do me that. Give me 1 second. Let me see if I have connection. Temp, Evernote. I'm using my cell phone data, so it might take some time. Let's try again. Please, on my knees. Yes, it's getting created. Now, while this is happening, let me just show you how to do it from the command line. So in order to deploy a function on GCP, we need the GCP SDK, and that provides a gcloud command. So you authenticate against the provider, and you set the context for a project. I have done that already. So I create a folder with a main function, a main module, and in that module, I have written some kind of 3 functions, and the main one is the first one. And what this is going to do is to hit another service that will return some books, filtering by author and language, right? So, yeah, just 2 to 3 functions that you probably might be familiar with this code. Actually, I haven't written them. I took this from another guy. So, yeah. Oh, the function finished. Let's go to the detail page. And since I have attached my function to an HTTP call, then in the trigger section, you can see the endpoint that the provider has created for me. So let's go in here, and hello world, right? And I haven't touched my machine, everything from the browser. But real applications are not like that. So if you see, let me just kind of go in here. Second, because it's common, and nervous. Let me just delete it by one button. So, what I have in here is just the main file, main.py file with the implementation of our functions, right? Nice, gcloud, cool. So, gcloud functions deployed, the name of the function. I have in my file 3 functions, but only one have to be the main one. So I have written in here the entry point, which is the main function, in which region is going to be deployed. Many developers, including me, don't take care about the region, and it's really very important because the closer your region is to your user, the less latency your users will suffer. And we just, yes, the one by default. Just spend 1 second thinking about that. The runtime and how we are going to call the function. In this occasion, by HTTP call. Let's just hit that and pray. And in the meantime, I have deployed a function before of this, and it's this one. It's basically the same one. And if you see it in here, it's the same code I was talking about before. And in the trigger section, you will see that is returning some bugs. And we can query our function by filters as well, and then it will give us another set of data. Right? Let's see if this finished. Yep, finished. So if I go back to the dashboard, I should see 3 functions, which is this one. Right? Remember that I call it B version 1. That is also be called by an HTTP endpoint. And something I forgot to mention is that, let's go back to this one. Sorry. You have a kind of a monitoring mechanism in the detail page, because you can see how many requests your function is getting. And this is really cool because Well, if you see anomalies in your traffic, you might need to take some actions. Because yes, it scales, but if you receive more traffic, you're going to pay more. So it's not nice when you have to pay for a DOS attack, right? So take care about it. Like put something in the middle before to reach your endpoint directly, like an API manager or something like that. Cool. Let's, by the way, I'm talking from here because my size. Second. Conclusions. Fast function as a service is another architectural approach for apps. It doesn't mean we all need to go with fast. It doesn't mean that you have to. And it doesn't mean that your entire app have to go with fast. You can have a hybrid model. Like whatever is required to be running always, don't put it in here. And if you have some crumbs on few endpoints, just move them to them so you can save money. Actually, I'm going to the third item. If you are not saving money with fast, you might doing this the wrong way. So think about it. Not all apps fits into this approach because the reason I just said. And finally, it autoscales, but remember that it will do it as much as the code inside your function will do. So if you connect to services that don't scale that well, it's not going to scale as you might expect. There are some references in here for more or less getting involved with this. And I have written an article for kind of explaining all the main concepts. If you are bored, you can go there and get more bored. Thank you very much.
Listo, fuerte aplauso para Jorge. Tenemos 5 minutos para preguntas. Si alguien tiene, por favor, me levante la mano.
Hi.
Hey.
I work in my previous company with Amazon Web Services like a year ago. And I remember that when we were implementing the solution, it was a perfect scenario. But we had some issues regarding when we were coding. We did some tests for the functions.
Yeah.
But for real testing, we had to always be deploying and testing basically with the browser or with curl. So what I'm asking is, do you know maybe that there is some improvements regarding this, the testing of the functions with real data?
Yeah, what I have done so far for local development is to put or to set my functions into Flash handlers. So like there is an endpoint in my local environment that calls the function and implementing, right? And with that, I can write testing or unit tests for it, right? But deploying this, is it's not going to work. So you need to adjust your CI, CD in order to don't take this handler, but to take the functions in order to move them to them. And yes, for integration testing, what I had done also is to deploy the functions to another environment and testing as a whole. Yeah, but the tricky part I figured is having this locally into Flash handlers, which is just one line calling the function and forwarding the request. Okay.
¿Alguien más? ¿Preguntas? Por acá.
Hi, Roman Kurchenko here. So you said You said there are two ways of running functions, like you could use a provider like Google or Amazon, and there are some on-premise platforms you can install. However, I have this question because providers are almost always good for small companies, so you don't have to pay for developing DevOps engineers who are going to manage your infrastructure and stuff. But then sometimes that happens that small companies transform to be in big enterprises. They sometimes grow or sometimes get acquired by big enterprises. And then for a big enterprise, in like 90% of chances,
90% what?
90% of chances, running own infrastructure is much more cost efficient than using some provider. So, and with that in mind, have you ever explored a way to have an easier way of escape from a provider to, let's say, a self-hosted solution for your cloud functions?
I'm afraid I haven't.
Thank you.
And just 1 second. The joke about the Polish is because my friend Sheshak, when I asked for, do you hate cloud providers, he was the one. Yeah, me. Oh.
Listo, una última pregunta, alguien, tal vez. ¿No? Ok, listo, muchísimas gracias. Un aplauso
Thank you.
nuevamente para Jorge.